Good evening, students. I hope you are all doing fine. How was your day? I hope it was good. So, we are back. What we are going to study? Indefinite integration. Okay, I can see there are some new students. So, let me introduce myself. My name is Keval Parmar and I am a professor of mathematics. I'll be teaching you mathematics. So, I hope you are excited to learn. We'll be continuing where we left yesterday, if you remember. Also, I guess yesterday I said ki we are going to start with definite integration, but then I thought ki maybe we should do some questions to practice, right? So I brought some nice questions for you all, which are important for your boards as well as for JW. So we'll fully complete with questions in definite integration today, and then from next lecture is on Thursday. Tomorrow is holiday. So from next lecture, Thursday, we'll start with definite integration. Got it? So yeah, yesterday we left it here, right? So we were doing, if you remember, this special integrals, right? This type. So if you remember, what were the steps? Divide numerator and denominator by cos square x. Then in denominator, write sec square x as 1 plus tan square x. And third step was put tan x equal to t. So let's use this here. But here directly it is not the format, right? So we can use the formula of cos 3 theta. So what is the formula of cos 3 theta? If you remember, integration of cos theta upon, it is 4 cos cube theta minus 3 cos theta d theta. Now, if you can see, there we can take cos common from the denominator and it will get cancelled with numerator. So I will be left with 1 upon 4 cos square theta minus 3 into d theta. Now this is our format. So what we'll do 3 steps. First, we'll divide numerator and denominator by cos square theta. So if I divide numerator by cos square theta, I will get 1 upon cos square theta, which is sec square theta. And in denominator, here cos square will get cancelled, minus 1 upon cos square. Again, we can write it as sec square theta. Correct? So after that, this sec square theta, so I have to write 1 plus tan square theta. So that means I can write it as sec square theta d theta upon 4 minus 3 into 1 plus tan square theta. I hope you are getting it. After this, we can simplify the denominator. So if I simplify the denominator, what I'll get? Numerator में I'll get sec square theta d theta upon denominator में 4 minus 3, which is 1 minus 3 tan square theta. After this, the most important or the simplest step is put tan theta is equals to t. Then I differentiate with respect to t. So what I'll get? I'll get sec square theta d theta is equals to dt. So if I substitute these both here, I can easily write in place of sec square theta d theta, I can write dt. Correct? So what I'll get? I'll get integration of dt upon 1 minus 3 tan square theta, which is t square. So if you remember this format, what is this format? I can write it as integration of dt upon 1 minus root 3t, the whole square. Correct? So what is this format? What is this format? This is integration of 1 upon a square minus x square. Do you remember this formula? 1 upon a square minus x square. क्या था फॉर्मूला? If you can remember, it was log mod a plus x upon a minus x plus c. So here in our case, in place of x, we have root 3t, and in place of a, we have 1. So my answer will be log mod 1 plus root 3t upon 1 minus root 3t plus c. Also, don't forget, we need to divide by coefficient of t. So we need to write 1 upon root 3. Why 1 upon root 3? Because it was the coefficient of t. It was coefficient of t. So we need to divide it with coefficient of t. Do you remember this rule of integration? And finally, if I resubstitute, what was t? Tan theta. So I will get 1 upon root 3 log mod of 1 plus root 3 tan theta upon 1 minus root 3 tan theta plus c. I hope it is clear till here. If it is clear, I told you yesterday, please make it more interactive. So even I will not get bored. So if it is clear, you can say yes, sir, or thumbs up. And if you have any doubt in this question, you can ask. So let's see what are your thoughts. You can type in the chat box or you can unmute yourselves and also talk. Come on, guys. Is this question clear? My voice and my screen sharing video all are okay, na? There is no lag and all. You can confirm that also. Yes or no? Come on, guys. Okay, fine. Chalo, very good. So let's move on to the next question or next format. Next format is this: integration of 1 upon a sin x plus b cos x plus c, where a, b, c are constants. A, B, C are constants. Got it? So this is also a special type of integral where the format is 1 upon a sin x plus b cos x plus c. So in this type of integral, what we'll do, here the angle is x. So what we do is we substitute tan of half angle is equals to t. So here that means we have to substitute tan x by 2 is equals to t. So if I differentiate with respect to x, what I'll get? I'll get sec square x by 2 into, by chain rule, 1 by 2 is equals to dt upon dx. If I cross multiply, I'll get sec square x by 2 dx is equals to 2 dt. So that means what is dx? Dx is equals to 2 dt upon sec square x by 2. What I can write sec square x by 2 as? 1 plus tan square x by 2. And what is tan x by 2? It is t. So 1 plus t square. So I got dx from here. And secondly, we can write sin x also as in half angle formula of tan. What can I write? 2 tan x by 2 upon 1 plus tan square x by 2. And what is tan x by 2? Tan x by 2 is t. So I can write 2t upon 1 plus t square. And lastly, also cos x. Cos x was 1 minus tan square upon 1 plus tan square. So by using these three substitutions, that means dx sin x की जगह पे this, and lastly cos x की जगह पे this, I can easily solve this type of integration. So without further ado, let's look at quickly look at an example. What will an example look like? Here. Integration of 1 upon 3 minus 2 sin x plus 5 cos x. It is same as this. So what will I do? The first step is the same. Tan of half angle. Here the angle is x. So half angle will be x by 2 is equals to t. Got it? So if I differentiate again the same procedure like this, I will finally get dx equals to 2 dt upon 1 plus t square. So that means dx is equals to 2 dt upon 1 plus t square. Is it clear? And what can I write? Sin x by 2. Sin x I can write 2t upon 1 plus t square. And cos x I can write 1 minus t square upon 1 plus t square. Now, if I substitute all this in the question, my integral will be integration of 1 upon 3 minus 2. In place of sin x, I can write 2t upon 1 plus t square plus 5. In place of cos x, I can write 1 minus t square upon 1 plus t square into, in place of dx, I can write 2. Oh, I made a mistake. No, it is 2 dt upon 1 plus t square. If I take LCM in the denominator, what I'll get? I'll get 3 into 1 plus t square minus. Here I'll get 2 to the 4t plus 5 into 1 minus t square. The whole upon 1 plus t square. And here it is 2 dt upon 1 plus t square. This 1 plus t square, this 1 plus t square will get cancelled. So I'll get integration of 2 dt upon, if I open the bracket here, so 3 plus 3t square minus 4t plus 5 minus 5t square. Correct? If I simplify the denominator, 2 to constant, it will come outside. So dt upon 3t square minus 5t square. So minus 2t square. This and this. And minus 4t and plus 5 plus 3. So plus 8. So here, from here, what can I write? We can take minus 2 common from denominator. It will get cut. So I will get minus integration of dt upon, since I took minus 2 common, the sign will change, t square plus 2t minus 4. I hope it is clear. And now, what is the format here? The format here is 1 upon quadratic. And what we do in 1 upon quadratic? We use completing square method. So if I use completing square method, I will get minus integration of dt upon t. I can write it as t square plus 2t. I'll add 1 and subtract 1. Please stay with me here. Please stay with me. I am skipping one step. I'll add 1 and I'll subtract 1. If I'll add 1, I will get t square plus 2t plus 1, which is t plus 1 the whole square. And minus 4 minus 1, the subtracted one, will be minus 5, which I can write it as root 5 ka square. Simple. So what is the answer here? Achha, if we can take the minus inside. So if I take the minus inside, I'll get integration of dt over root 5 ka square minus t plus 1 the whole square. So what this format looks like, it is exactly same as previous question, this one. A square minus x square, if you remember, a square minus x square. So in place of a, this is root 5, and in place of x, it is t plus 1. So what was the answer? It was log of, 1 second, it was It was log of mod A minus, sorry, plus x upon A minus x plus c. Lastly, we resubstitute the value of t. What is the value of t? The value of t is tan x by 2. So that means I can rearrange it as root 5 plus 1 plus tan x by 2 upon root 5 minus 1 minus tan x by 2 plus c. This is my answer. I hope it is clear. Now, if it is clear, then you can say in the chat box, or if you have any doubt, you can also say yes, no, anything. Or if you want to go through the sum again, we can take the time also. Then we'll proceed further. Chalo, what are your thoughts? All good? Did you understand this? I hope yes. I hope I'm teaching well. I mean, you're understanding, right? Yes, no, come on, you can write at least. खाली मैं ही बोल रहा हूँ. Hello, is the voice clear? Is the question clear? Hello, response do, come on. Is it fine? Did you understood? Arey, come on. Hello, is my voice clear? So did you understood? All good? Should we proceed further? Okay, fine. Chalo. Let's move on to the next question. Now, the thing I was saying that your typical types and are all over. These are some interesting questions here, which we are going to do now. These are basically from your NCRT. This one is from NCRT का favorite. NCRT का favorite मतलब boards का favorite. Got it? So this is from NCRT. Here what we do, we replicate the angle of denominator and numerator. So what we do, we replicate angle of denominator in numerator. So in denominator, what is the angle of denominator? It is x minus a. So we'll try to replicate it in numerator. So I'll get cos of x minus a plus 2a. I can write it like this. X minus a plus 2a upon sine of x minus a dx. Or you can many a times students also substitute, like put x minus a equals to t. Any you can do, out of both you can do. If I put x minus a equals to t, then also it will be the same thing, right? So here I can see this is cos a plus b. What is cos a plus b? It is cos a cos b minus sin a sin b. So I can write cos x minus a into cos 2a minus sin x minus a into sin 2a. And in the denominator, I splitted the denominator in both. So this is sine x minus a upon sine x minus a, the whole dx. Correct? Here, sine x minus a will get cancelled. And here, as you can see, cos x minus a upon sine x minus a, it will become cot x minus a. So I can write it as cos 2a तो बाहर आ जाएगा because cos 2a is constant. Integration of cot x minus a dx minus here sin 2a is constant बाहर आ जाएगा sin 2a integration of क्या बचा 1 dx. So what I'll get, what is integration of cot का integration, that will be cos 2a into ln mod sin, cos का integration ln mod sin, correct, minus sin 2a into 1 का integration is x plus c. This is my answer. So simple. Got it? So what should you remember in these types of questions? That we have to replicate angle of denominator in numerator. If you do so, then use compound angles and then the integration will be easy. Got it? Clear hai? Yes, no? Come on guys. ऐसा तुम लोग करोगे तो it's be very boring. Huh? You can at least yes sir, no sir, हाँ ना, okay, good evening, goodbye. Chalo, should we move on to next question? Come on. Is it clear? Yes, no? Okay, very good. Chalo. Let's move on to the next question. This one. This is also the same, but this is a better version. Same, this is NCERT. Same as previous question, but it is a better version. Better version means here we have to like arrange the angle of denominator in numerator. So what we can do is see 2x plus a, 2x plus ba. Got it? So what we can do here? What I'll do is see. I'll multiply and divide by a minus b. Chalo, sine a minus b. This I did on my own. So I multiplied with sine a minus b and I divided with sine a minus b. A minus b is a constant, so no issues, right? And in denominator we have sine 2x plus a into sine 2x plus b. Now, see how smartly ये तो चलता ही रहेगा, बार बार मैं नहीं लिख रहा हूँ. I arrange the angle in denominator in numerator. So a minus b को I can write 2x plus a minus 2x plus b. This is the most important step here. Upon sine 2x plus a into sine 2x plus b dx. या फिर बहुत लोग क्या करता है, as I told you many times, you just assume this as t or this. Anyone you can assume it as t. But there is a reason that I am asking you to do this, because you'll learn manipulation. And in integration, believe me, nothing is more important than manipulating the given function so that it becomes integrable. So that's why I want you to learn the manipulation. So I can write it like this. So यहाँ पे ऊपर क्या लगे अभी formula, which formula? Sin A minus B. Sine A minus B. So here it is same 1 upon what is sine A minus B? It is sine A. इसको कैपिटल ए मान रहा हूं चलेगा ना इट्स फाइन sin A cos B just for like simplification minus cos A sin B and जो डिनोमिनेटर में था अगेन व्हाट आई डिड आई स्प्लिटेड सो डिनोमिनेटर में आई गॉट sin A sin B and here also sin A sin B. Correct? If this is A, then this is basically A, this is B. So here you can clearly see sin A got cancelled and here sin B got cancelled, the whole dx. So what I am left with is, बार तो ये पढ़ा ही है बार, integration of here cos B upon sin B. It is cot B, वापिस लिख देते B कौन था 2x plus B minus cos A upon sin A. Cos A upon sin A is cot A. Cot A कौन था 2x plus A dx. Now both of this integration are simple that we know cot का integration is log mod sin. So that means I can write it as 1 upon this into cot का integration ln mod sin 2x plus b. Don't forget upon 2. Why upon 2? Because it is coefficient of x minus ln mod 2 ln mod sin आएगा ना ln mod sin 2x plus a upon 2 plus c. Now ये 2 को I can take बाहर, so I'll get 1 upon 2 sin a minus b. अंदर क्या बचा अंदर ln minus ln, so I can use the property of log. I can write it as ln of sin 2x plus b upon sin 2x plus a plus c. This is my answer. I hope it is clear. Now the main thing is here, why did I multiply and divided by sine? The main doubt you should get is why did I multiply and divided by sine? Why not cos? यहाँ पे मैं cos भी ले सकता था ना. Why not cos? So here you have to see if this is same. Same means both are sine. Both are sine. Or if suppose both are cos. So same implies use sine. And if here there were different, means एक sin होता और एक cos. So different implies use cos. So agar suppose I would have cos and here sin. So I would have chosen cos to multiply and divided by. I am repeating again. If in the denominator both are same means sin or cos, then multiply and divide by sin. I multiplied and divide by sin. In denominator if there are different means sin एक और दूसरा cos, then we multiply and divide by cos, then we'll use cos. I hope it is clear. So here it was same, therefore we multiplied and divided by sin, and if different, multiplied and divided by cos. The benefit is same. You will see yourself. Got it? If it is clear, this is very important question of NCERT. This is also asked in JEE mains. Same question it was asked. Sin upon we should multiply and divided by. Got it? If this is clear, we can move forward. Clear till here? Yes, no, anyone? क्लियर ना कैसे करना है साइन साइन या साइन कॉस जो भी आया ओके वेरी गुड चलो लेट्स मूव ऑन टू द नेक्स्ट this is a similar question same replicate angle of denominator and numerator So means I have to write 6x in terms of 10x and 4x. So I can write it as sine 10x minus 4x upon sine 10x into sine 4x dx. Got it? See here. यहाँ पे क्या बोला था मैंने? सेम है तो यूज साइन. डिनोमिनेटर में देखो, सी इट इज सेम. साइन साइन, दैट मीन्स न्यूमरेटर में भी साइन है. इट इज ऑटो एडजस्टेड. अगर न्यूमरेटर में कॉस होता, इफ वी वुड हैव कॉस, देन द क्वेश्चन वुड नॉट बी सॉल्वेबल. So in numerator I can write sin a minus b. What is sin a minus b? Sin a cos b minus cos a sin b upon, sorry, हाँ, cos a sin b upon, वापिस हम लोग क्या करेंगे? Will split the denominator in both. So sin 10x into sin 4x. यहाँ पे sin 10x into sin 4x the whole dx. Here sin and sin will get cancelled. So we'll be left with integration of cot 4x minus cot 10x dx. And integration of cot, again very simple. What is integration of cot? It is log mod of sin 4x, but here upon 4, minus log mod of sin 10x upon 10 plus c. This is my answer. I hope it is clear. This was the same question. Let's look at another good question, which is this one. Now, let me tell you, this is again a good question of particular format. What format you can see in general? Let me write it here. The format we can see is a sine plus minus b cos upon c sine plus minus d cos, or the other one is a e raised to x plus b upon c e raised to x plus d. So if any of this format comes, this is this one. ये वाला तो ये है ना. What we do is we write numerator is equals to a into denominator plus b into derivative of denominator. We write it as numerator as a into denominator plus b into derivative of denominator. Now see what happens when we write it as. Numerator में cos को I am writing c, don't mind, and sin को I am writing s. आलसी हूँ मैं बहुत, I am very lazy. So I'll write cos को c, sin को s. So numerator is 3 cos minus 4 sin is equals to a into denominator 7 cos minus 2 sin plus b into derivative of denominator. So it will be minus 7 sin. Cos ka derivative is minus sin minus 2 cos. Now if you remember partial fractions, we want the values of a and b. So how do we used to get values of a and b from partial fractions? We used to compare the coefficient. So here 3 cos minus 4 sin will be equal to cos वाले साथ में लिख लेते हैं ना. So if I write this cos and this cos साथ में, cos को बाहर ले लिया, अंदर क्या बचेगा? 7a minus 2b प्लस सिमिलरली साइन को साथ में लिखूंगा तो क्या मिलेगा? माइनस 2a minus 7b. So if I compare the coefficients, so that means cos का compare करो, 7a minus 2b is equals to 3. And अगर मैं sin का compare करूँ तो minus 2a minus 7b is equals to minus 4. That is, I can write 2a plus 7b is equals to 4. Now what I'll do, I solve simultaneously to get value of a and b. तो इसको multiply by 7 and इसको multiply by 2. So if I solve simultaneously, I get 49a minus 7 to the 14b is equals to 21 and इसको 4a plus 14b is equals to 8. क्या करने वाला हूं मैं? Add. दोनों को add. If I add, this is cancelled. 53a is equals to 21 plus 8. 29 implies what I get? A 29 by 53. Similarly, I'll get B something. Now this is, I am hoping you all know. We simultaneous solve karna, so you will have studied in 9th and 10th standard. So I'm not calculating it. I'm just hoping that you will get B. So now what I'll do, I'll write numerator or I'll substitute A and B here. Right? That means my integral will become, ये जो लिखा है कलर ही नहीं है, ये जो लिखा है, in place of this I can use this. Correct? In place of this I can use this. So that means I can write A into 7 cos minus 2 sin plus B into minus 7 sin minus 2 cos अपॉन डिनोमिनेटर को मैं स्प्लिट कर रहा हूं. 7 cos minus 2 sin 7 cos minus 2 sin the whole dx. So यहां से तो ये और ये कैंसिल ही हो जाएगा. So यहाँ पे बचेगा a इंटीग्रेशन ऑफ 1 dx सिंपल प्लस b इंटीग्रेशन ऑफ minus 7s minus 2 cos upon 7 cos minus 2 sin dx. Now, very clearly you can see if the denominator is f of x, then the numerator is f dash of x. You can see very clearly. अरे हम लोग ने ये लिया था ना डेरिवेटिव ऑफ डिनोमिनेटर. सो denominator is f of x, so it is numerator is f dash of x. Correct? So if I put f of x equals to t, that means f dash of x dx will be equals to dt. So that means here I'll get ax, 1 का integration is x, plus b into integration of 1 upon t dt. That means ax plus b into 1 upon t का integration log mod of t. What was t? F of x. What is f of x? 7 cos minus 2 sin plus c. Now just we have to value of a and b. A का value क्या था? 29 by 53 plus. Similarly, you will get the value of b. ln mod 7 cos x minus 2 sin x plus c. This is my answer. Got it? Please remember these formats. This one, this both. Right? If any of these comes, we can directly use this question. Got it? Or the steps. I hope it is clear. The steps are pretty simple. You have to do exactly the same. Don't try to do anything else because answer nahi aayega. That's why they have made a specific method for these types of questions. Got it? This was a good question. So I hope you got it. You can say yes, no again in the chat. Come on, guys. Is it clear? Yes. Is it clear? Okay, very good. Chalo. So let's see the next type. This is the next type. Now, this is also a very typical question where we have sine some power into cos some power, right? Sine some power into cos of some power. So in these types of question, what we'll do is, what can we do? Sine some power, cos some power. Come on, you can say if you have done. We'll separate one power from the odd one. So the odd one here is sine. So what we'll do is we'll separate one from the odd power so that both of them become even. So I'll get sine raised to 4x into cos raised to 8x. Now, if you remember this or if you got this, sine x dx, that means I need to put cos x equals to t. That means before putting, I'll adjust this. Is sine raised to 4 ko I can write sine square the whole square. And sine square ko I can write 1 minus cos square into cos raised to 8x into sin x dx. Now I'll put cos x equals to t. That means sin x dx will be equal to minus dt. I adjusted the minus this side. So if I substitute this here, I'll get integration of 1 minus t square the whole square. Correct? Into t raised to 8 into sin x dx will be dt. Now it became very simple. We just need to open this bracket, the whole square one. How will open it? A square minus 2ab plus b square into t raised to 8 dt. What I'll get? Come on, guys. What I'll get? I'll multiply t raised to 8 here. So I'll get t raised to 8 minus 2t raised to 10 plus indices. Indices में power क्या हो जाता है? Add. So t raised to 12 dt. T raised to 12 dt. Correct? And the integration is very simple. What is t raised to 8 ka integration? T raised to 9 upon 9 minus 2 t raised to 11 upon 11 plus t raised to 13 upon 13 plus c. Now it's time to resubstitute. What I'll resubstitute as t कौन था? Cos. So cos 9x upon 9 minus 2 cos 11x upon 11 plus cos 13x or ratio 13x upon 13 plus c. This is my answer. I hope it is clear. Now I'm very thirsty, so 2 minutes I'll drink some water and I'll be back. Till then, you can think, or if you understood this, you can think about the next question. It is a very interesting question, a good question. You can think about the next question. I'll give you 30 seconds. Come on. Chalo, I'm back. Uh, did you think this question we'll be doing? You'll not believe we'll be doing by using integration by parts. Now, how can we use integration by parts? Many of you will say ki we how we did log 1 into kar lo. But here the more smartness is not 1 into. What I can write it as, I'll write it as integration of sec x into sec square x dx. Now I have to assume the first function and the second function. The second function should be assumed such that it should be integrable. If you remember yesterday, I did not I had write it in bold letters key for selecting first function and second function. Mostly we use eyelet rule, if you remember. But here eyelet rule will not work because both of them are trigonometric. So the main logic behind selecting the first function and the second function is that the second function should be integrable. Second function should be integrable. I had mentioned it in a slide in bold highlighted letters. Select the second function which is integrable. So here sec x and sec square x both are integrable. But the more easier one or the more standard one to integrate is sec square x, because sec square x ka integration is 10x. Sec x का integration is log mod sec x plus 10x. That ganda एकदम बेकार formula. So that's why I'll use this as second function and I'll use this as first function. I hope it is clear. Now, bus just use integration by parts and essay you'll get your answer. Very good question. We can write it as I. Let this be I. Right? So what was the formula? First function as it is, integration of second function which is 10x minus integration of derivative of first function which is sec x into 10x into integration of second function which is 10x dx. I hope it is clear. This is derivative of first function. This is integration of second function. So I'll get sec x into 10x minus integration of sec x into 10x into 10x is 10 square x dx. Now here I can write 10 square x as sec square x minus 1. Sec square x minus 1 dx. Now if I open the bracket, I'll get integration of sec cube x dx, and this minus will become plus integration of sec x dx. And here to वही चल रहा था. What was that? Sec x into 10x. This was I. Now if you remember, here there is an appearance of I. See, integration of sec cube x is I. So that means I can write this as I equals to, sorry, what did I write? I equals to, let me divide it. I equals to sec x into 10x minus I plus integration of sec x dx. Now minus I will come to left hand side. I'll get 2i is equals to sec x into 10x plus, what is integration of sec x? It is log mod sec x plus 10x plus c. Now if I wanted the value of I, so I'll just send this to this side. So upon 2 upon 2. This is my answer. The integration part is very simple, but this manipulation to select the function which is first, which is second, to write sec cube x as sec x into sec square x, it is very good manipulation. It is also obviously from NCRT. There are some very good questions from NCRT. So before directly jumping into your modules and so, you first need to thoroughly means thoroughly solve NCRT. As you also do this in chemistry, right? Chemistry में तो teacher must say कि बस only study NCRT, pit to pit, every page you need to learn. So for maths also I'll suggest कि first before solving the modules and all, be thorough with NCRT. And if you are thorough with NCRT, then it is very good. Then you can do a level up, which is the modules. Got it? Let's look at the next question. Now some questions from entrance exam. So here, I'll give you 30 seconds to think what can I do, as it is from entrance exam and a good question. We done this similar. Cos का odd power. What we can do cos का odd power? अभी क्या just few time ago. I'll give you 30 seconds to prepare. What can we do? Cos का odd power. Got it? Odd power में what I said is separate one power from the odd one. So I can write it as cos 4x into cos x dx. So cos x dx को साथ में देखा. So what do I think? Cos x dx means sin x को t रखना है. So that means sin x को t रखने के लिए cos raised to 4 को I can write cos square x the whole square, and cos square x को I can write 1 minus sin square x into cos x dx. Correct? So now I'll put sin x equals to t. That means cos x dx will be equals to dt. So now my integral will become 1 minus t square, the whole square dt. If I open the bracket, I'll get a square minus 2ab plus b square dt. The integration is very simple. What is the integration? T minus 2t cube by 3 plus t raised to 5 by 5 plus c. Now if I resubstitute t, what was t? It was sine x. So this is equal to sine x minus 2 by 3 sine 3x plus 1 by 5 sine 5x plus c. So if you can see here, what is the value of p and what is the value of q? So we can compare it and we can write p is equals to 2 by 3, q is equals to 1 by 5. So they want p plus q. P plus q is 2 by 3 plus 1 by 5, which is, I guess, 13 by 15, which is option A. Simple. Got it? I hope it is clear. So this was all. These were all the good questions that I thought should solve with you. And again, I would like to say, be thorough with NCRT first, and then try to solve the other questions. Here again, if you want, or if you have any doubt now, you can ask, or you can we'll end the session here. And yes, I'll say that tomorrow is your holiday. Thursday, we'll be starting with definite integration. We are fully and completely done with indefinite integration. And from Thursday, we'll be starting with definite integration. So if you have no doubts and everything is fine, then we can end the session. Correct? Correct. Yes, no, come on guys, we can end the session. I hope. अच्छा, thank you आ गया पहले. Okay, no problem. Chalo. Thank you all. If no doubts, we'll end the session. Bye bye. Take care, everyone. Tata.